what if I told you that spending just 1 hour near a black hole could mean 50 years pass for everyone else? You'd think, that's impossible. Time doesn't work like that. But in Interstellar, it does. And shockingly, science backs it up. Let's go back to that scene. Cooper and the crew land on Miller's planet, a planet orbiting dangerously close to a supermassive black hole, Gargantua. They face towering waves, a ticking soundtrack, literally, and the stress of limited fuel. They stay on the surface for just over 3 hours. When they finally return to the Endurance, 23 years have passed. Romilly, left behind in orbit, has aged decades. The crew barely aged at all. That moment, it hits emotionally. But it's also grounded in real physics. To understand this, we need to let go of a familiar idea, that time ticks the same for everyone, everywhere. Einstein proved, time is relative. The stronger the gravity, the slower time flows. So next to a black hole, where gravity is monstrous, time literally slows down compared to places like Earth. This isn't theory anymore. It's been measured, tested, and proven. Newton gave us gravity as a force. Two masses attract, simple, beautiful math. But Einstein flipped the script. He said mass bends the fabric of space-time, and objects, including light and time itself, follow those curves. He called it general relativity, and it changed everything. In his famous thought experiment, Einstein imagined a person inside a rocket, unable to see outside. If the rocket accelerates upward at 9.8 ms2, the person feels just like they're on Earth. Now switch it around. A person standing on Earth feels gravity not as a pull, but as a constant acceleration downward. This realization led to one of his biggest ideas. Gravity and acceleration are indistinguishable, which explains why satellites, like GPS, must account for time dilation. Otherwise, your navigation would be kilometers off within minutes. Okay, back to Gargantua. This black hole isn't ordinary, it's supermassive and spinning. Its rotation literally drags space-time around with it, a phenomenon called frame dragging. Miller's planet sits just outside the event horizon. That's why time is so drastically dilated. 1 hour down there equals 7 Earth years. Spend 3 hours? You've lost over 2 decades back home. You might be thinking, this all sounds theoretical. Has it ever been proven? In 1919, astronomer Arthur Eddington tested Einstein's theory during a solar eclipse. He observed that starlight near the sun was bent, meaning gravity had curved space itself, and thus bent light. This confirmed gravity warps space, and therefore time. It was the first observational proof that Einstein was right. Let's get weird. Imagine looking at someone standing near a black hole from a safe distance. To you, they seem frozen, moving in slow motion. But to them, time feels completely normal. Their heart beats. Their watch ticks. They live their life like nothing's wrong because their time hasn't changed. Yours has sped up relative to theirs. That's gravitational time dilation in action. And that brings up something deeper. Is time even real in an objective sense? Or is it always a matter of perspective? Einstein didn't just change physics, he changed philosophy. Today, understanding time dilation isn't just sci-fi fan service. It helps scientists plan missions near large gravitational bodies. It shapes the design of clocks, satellites, and navigation systems. It's even being studied for time-sensitive data transmission in quantum computing. And if we ever travel close to a black hole, this knowledge could be the difference between survival and vanishing from time. Interstellar didn't just get the science mostly right, it used that science to make us feel something. The cost of time. The fragility of human moments. The heartbreak of watching someone age without you. It's a film about love and physics, and maybe that's the most honest science fiction of all. If this blew your mind as much as Interstellar did, like this video, subscribe for weekly deep dives into space, science and sci-fi, and tell me, if you had 1 hour near a black hole, what would you do with it?